All right, fourth hour. We need to go through problem number 1 on this paper. When a person takes a dosage of I milligrams of ibuprofen, the amount A in milligrams of medication remaining in the person's bloodstream after T hours can be modeled by the equation A equals I times 0.71 raised to the power of T. We want to find the amount of ibuprofen remaining in a person's bloodstream for the given dosage and elapsed time since the medication was taken. So, for part A, we're going to use the formula A equals I times 0.71 raised to the T power. Our initial dosage is 200 milligrams. So there's what our formula looks like. Oh, excuse me. 200 milligrams for 1.5 hours. So type that into your calculator, pause the video, and see if you get what I got. You should get 119.7 milligrams. That's how much medication is left in the bloodstream with an initial dosage of 200 milligrams after 1.5 hours. The second example, we want to use the same formula, but our initial dosage is 325 milligrams. So we need to multiply that by 0.71, and we want to know how much medication is in the bloodstream after 3.5 hours. So type that into your calculator and see if you get what I got. Go ahead and pause the video. All right, you should get 98.0 milligrams. Our final example, we want to know how much medication is left in the bloodstream with an initial dosage of 400 milligrams after 5 hours. So that's 400 times 0.71 raised to the 5th power. Pause the video, type that in your calculator, and see if you get what I get. You should get 72.2 milligrams. All right. Fourth hour, we're still on you. Let's look at number 2. Bike costs. You buy a new bike for $200. The value of the bike decreases by 25% each year. Part A wants us to write a model giving the mountain bike's value in dollars after T years. Well, we want to use the formula. I believe it's called fixed percent. Let's see, the formula we're going to use is fixed percent each year. So y equals A times 1. We're going to use minus because it's going to be decreasing in value, minus r raised to the t power. So here we go. Part A, we want an initial value of $200, so y equals 200. We're going to multiply that by 1 minus 0.25. And I got the 0.25 from 25%. I moved the decimal over 2 units. That is not very dark. Let me get a pen. Let's see if this pen works better. All right, y equals 200, which is the initial value of the bike, times 1 minus 0.25 raised to the t power. So that's part A. Part B says graph the model. Well, if our initial value for our bicycle is $200, then we want to start up here at y equals $200 and time equal to 0. And from that point, our bike is going to decrease in value. So there's what our graph should look like. Part C says estimate when the value of the bike will be $100. So we want to find out when y is 100. So our initial amount, $200, or the initial value of the bike is $200. We're going to multiply that by 1 minus 0.25 raised to the t power. So we're going to divide both sides by 200. $200 cancels on the right hand side. We're left with 1/2 equals 0.75 raised to the power of t. Now we want to take the log of both sides. The log of 1/2 is equal to t times the log of 0.75. So dividing both sides by the log of 0.75, you should end up with 2.4 years. It will take 2.4 years for the value of the bike to go from $200 down to $100.